Hey guys, so today I'm going to be showing you how to never worry about package management, never deal with conda, and never have to battle with Cuda ever again with virtual environments. So UV is already fairly known, but UV is the reason why all of this, ease in this process exists. And so UV is a package manager and so much more that's written on Rust. And so it's just in general, when you're installing pip packages, it's 10 to 100 times faster. It's so fast, and you have to install a lot of libraries. But more importantly, I think that it has the best way to manage virtual environments, install packages for a specific code base, and just ensure that your code literally always is working. So the first thing you want to do is come and install UV, and then depending on whether you're on Mac OS or Windows, I primarily focus on Windows and Linux, you're going to grab it from here. What I recommend you actually do before you run this PowerShell command and install it through PowerShell or curl on Mac is actually go ahead and delete and remove almost everything that you can find. Not on Mac, because Mac has default Python, but delete any conda, delete Python if you've installed different versions of Python, and then just install one base version of Python, because you'll thank me later. It's just helpful for some things. And so just keep the one like Python 3.12 or 3.13, whatever's the latest. But once you've removed pretty much everything, conda, Python, and you just have the one installation, go ahead and run this command. So once you have UV on your computer, you'll see that there are here lots of recommendations to get started and things like that. But today what I'm going to be teaching you is how to ensure that you can create virtual environments really quickly and easily, just step by step. Make sure that you know what Python versions and stuff like that you have, but more importantly, show you sort of the process in making sure that you always have Cuda compiled when you install Pytorch in a virtual environment. So when you go to install a package, like today, I'm going to be installing Orpheus text-to-speech. It's a very nice, natural text-to-speech model, and I wouldn't be able to do that really easily without a Cuda virtual environment. And if I just installed this on my regular Python, I'd probably run into issues where packages conflict and stuff like that. So I'll show you sort of the step-by-step and what you should do. Now, before we do that, the first thing you should know is that whatever package or whatever code base you're trying to install, the best starting point is just figure out which version of Python it's going to be using. So if you look in the code base, typically it'll be mentioned, and if it's not mentioned, usually for any kind of like any kind of code that they've done their own fine tuning and stuff like that, Python 3.10 for whatever reason is probably safe. But yeah, above 3.12 sometimes is not still supported if they're newer code bases. But just in general, you can remember that as a rule of thumb, but you should always look for it. In this case, I don't know. I'm going to go for 3.10 or 3.12. We'll just try them both. I could look in the code base more, but in any case, we'll take a pause and I'll actually go to my terminal and show you what you need to do to get UV set up and why it's so good. So I'll show you now inside of Cursor, because this is the actual code base that we want to get working and make sure that we have the virtual environment for it. So the first thing that you need to do is when you first install UV is you should probably go to UV Python list and see what comes up. So this will automatically find any installations of Python on your computer, and it's also going to help you to manage them, and it's going to know how to use them. You can see here I have lots of them, but if you don't have lots of installations and you just have like 3.9 or 3.10 or whatever, you can go UV Python install, I think, and then 3. Whatever. So you can see there, like for anything that's missing, you could just quite literally install it in that way. The way that you typically run packages is with UV run, and then like ty.py would run that Python file. But it's not that simple, but UV does have its own way to go UV run or UV pip install. And the reason why is just because that's essentially going to use its package management for running things. But you can still run things as per usual with just pip install with Python 3, whatever. However, it is going to try to prioritize automatically if you have a virtual environment file in that folder. But when you are making one, there's a very simple step-by-step. A lot of people actually use UV in this way. They'll go UV Venv, and then you can set the version, but they'll just go UV Venv like this. You can see that this is going to create a Venv for us, and this is going to be UV 3.12.5, and then they'll go, so I have a little alias. You can, on your Windows, if you're on Windows, you can go Notepad, and then Profile like that, and it'll open a Notepad where you can actually create shortcuts, aliases. So you can see here, I have one that just goes like this, and it activates, all it does is run this, and it activates the virtual environment. So now we have it active, and we could go UV pip install, and then I would do -r requirements, and we can install the requirements for this particular code base. But you're going to notice if I do that, it will install, it will try to install Torch, and it's going to not work. Like Cuda won't be enabled, it's not going to work, and that's just like the crux of the issue, right? It's really annoying. So this still can kind of work for simple packages, but it's not really like the safest way to create a virtual environment specifically for installing a large batch of requirements files and making sure that if you already have Cuda on your computer, you can utilize it. So what I recommend instead is, and you can still do this, by the way, it's just when you're dealing with Pytorch, this is something that you'll run into a lot. So what I'm going to do is actually go ahead and delete this, and so now we don't have this Venv anymore, and I'll just kill this terminal and we'll get a new one. So now essentially what we need to do is, instead of UV Venv, you want to start with UV init, and the key that I mentioned before is whichever Python version you think that you need, you're going to set that. And so you'll have to have pre-downloaded it, but now you can just pick. So let's say 3.12, we'll try that out. So now I've went init instead. I've started with init, and then same thing, I can actually go UV Venv, and same thing, we'll go 12. And so now we've initialized and created the virtual environment. And so this is going to give us actually some new files. We'll have a hello, which is interesting, but we have a hello file created, we have a Py project created, and we have a README created. Now, typically you don't need to super worry about most of these except for the Py project. So you can see it's 3.12. The nice thing about doing this and specifying the version is that you'll always have the version that that code base needs. The other thing too is you don't have to do that, and you can just go UV init on its own. It will default to whatever your default Python version is, which you can set, and you can go to the UV docs and change that as well. So now we want to make sure that we install Pytorch properly. So we know that this package uses Pytorch. We're not going to install it just through the requirements. The first thing you're going to do after you UV init and UV Venv is get the latest Pytorch for that particular for whatever Cuda you have on your computer. And so I'll go ahead and grab that command now. So I'm fairly sure I have 12.6 on this computer, but I can go now UV pip install, and then the torch install command. Now, some particular code bases are going to specify that you install a certain version. I just had to activate the environment again, so now I'll do that again. UV pip install. So some are going to ask that you install a particular older version of Pytorch, and that's fine. You should just get the command for that and then install that older version. But in this case, we're going to just attempt with the latest. And so why we're installing it first is because, well, we know this particular code base requires Torch. So instead of battle with Pytorch, the first thing we're going to do is just initialize, create the Venv, and on top of that, we're going to just install it. And so once this is done, I'll show you what you would do next. Okay, so Pytorch and these types of packages, they're unique in that instead of just UV pip installing and then UV running and having them work perfectly, we're having to use this UV init, and that's just really the crux of getting this to work every time, is just following these steps. So the next thing you're going to do is go UV add. So, and then you're going to add those packages. And so when you go UV add, you'll notice that it's already adding it to the dependencies. And this essentially creates sort of a spec for this folder that we're always going to be following. And the same thing we're going to do with UV add -r requirements.txt and add the rest of what's listed there in the requirements. And so this is essentially creating like a super locked in container that anything being run in this folder is going to be very rigidly following these packages, this virtual environment. But on top of just the virtual environment, specifically sort of the system packages that we're adding and setting here. So now we have done what I just said we should do. So we've run everything as we should. And so now we have app.py. So I'm predicting that because I don't have spaces, I'm trying to run a radio demo here, but let's try it. So if we go uv run app.py, we may run into some issues, but we did install, for the most part, pretty much everything for this package from scratch, and this is my first time running it. And you'll see that you're going to get a lot further with ensuring that you have Cuda Pytorch, that kind of thing, on the first one. So you see, like it's already starting to work and download the models, and it's going to use Cuda here. So the Cuda is available because in this package now, if I was to go to hello, which is great that the hello is actually here, because then you can go and you could create a script that would just print if torch is available. I can show you there. So if I just did that, and if I ran this in this, if I go new terminal here, and I just go, I activate the environment, uv run hello.py, you'll see that it'll say true. So typically when you go uv venv and you activate it and you try to install torch and stuff just with pip install or uv pip install, you run into a ton of issues, or you install it through requirements. So this is a little tutorial to make sure that you always have a virtual environment working perfectly with Pytorch, compiled with Cuda, and everything is going to be good to go. And so then the nice thing is everything's containerized in your Venv. When you want to clear up the space, you just go ahead and delete this Venv folder. And another little tip too you can do is uv cache clean, and this will wipe out all of your Python downloads and installations. I ran this morning just to have a clean cache and cleared up 70 gigs of space. So UV is the GOAT, and you'll see when you install like 50 packages in a requirements file how good UV can be. But you never have to worry about conda. You never have to worry about things not working. You'll see, UV is just a dream to work with, and also to have all your Python installations as just, a clickable or choosable list is really helpful. So I hope this video is helpful for you guys. And you can follow me and on Twitter as well. I appreciate if you follow me and interact with me there, as well as my Discord server below, and my website as well if you need to contact me for any AI consulting.